That's as best of an explanation as we could come up. Because if everything shrinks, everything comes down to this, it must come to something. It can't probably come to absolutely nothing. And even if it does, then what triggers the explosion? Now, let me ask you this question. Yeah. So do you think the comparison of Big Bang and whatever propelled Big Bang, so to speak, do you think that's a fair comparison to the concept of God?
I think it depends on how you're going to define God.
Bam, and we are recording. I was going to say that we are live, but it's not going to be alive. Although perhaps I should. Do you go live on YouTube? I've glimpsed at your channel. Never live, always pre-recorded videos.
Yeah, because I do so much with post-production, you know, in the way of images and cartoon characters and such. That
yeah, that's good.
It's all pre-recorded.
Yeah, so it's got to be edited post recording. I think it's pretty interesting. You've had access to big names. You know, I can't but name drop some people. So Neil deGrasse Tyson. You know, Lawrence Krauss. You know, who else?
Oh boy, there was Sylvia Earle.
Yeah.
Who is a renowned oceanographer. Kathy Sullivan. Yeah. Who was, I believe, the first American woman to do a spacewalk, and she was part of. She was one of the astronauts who helped launch Hubble.
Wow, that's impressive. And I'm on. So first of all, how long have you been running your channel? Is it? Would I be correct to say that it's relatively new?
The Cosmic Companion has been around since 2018, and I originally started doing. I was writing articles because that's what I had done before this. I had written about 10,000 scientific articles. And so first I started doing that, and then one of the astronauts I was writing, one of the couple of scientists I was writing about were doing work just down the street from my house. I live near the University of Arizona. And so I thought, oh wow, it would be great to go and talk with them, take them out to lunch, you know, set up a recorder, and we did that. And I was like, oh wow, that was a heck of a lot of fun. Hey, I could record with people in other parts of the world too. And so the podcast started, and I was like, I could do video, and then I could make the video a lot of fun. Ooh, I can do this, I can do that. Now I have like this huge like multimodal, like syncretic blend of all these different ways.
How do you go about advertising your channel? Have you even done any sort of promotion advertising on other platforms, or have you had other big famous people promote your channel or anything like that? Is that even a purpose of yours, to make the channel bigger and bigger?
Well, I mean, you know, I think it's always great to get people to like the show.
Right.
And that's of course a huge goal. But I tend to just put all of my efforts into developing the best show I can, and I'm, you know, running, and I really am glad with the way that, you know, people are reacting. You know, just, you know.
Has the feedback been predominantly positive? Any criticism at all?
If you're gonna get out there at all, especially as a creator, there's gonna be some criticism, but there's so much positive feedback. I mean, over the last couple of months, we've won all sorts of film awards.
Really?
You know, around the world, both for the show, The Cosmic Companion, our weekly show, as well as some of the short films that we're putting out.
Interesting. So the Cosmic Companion show is airing somewhere? Is it an internet show, so to speak, or is it airing on some channel somewhere?
Right now it's out on the usual places on the internet. Just search for The Cosmic Companion, or at the cosmiccompanion.com, .net, .tv.
Okay.
And but it would be just fantastic to see it out on a streaming service somewhere at some point.
When it came to Neil deGrasse Tyson, how did that happen? Did you get connected through somebody else, any mutual friends, acquaintances? If you don't mind saying on that, because that's not a problem.
I actually do. I'm fortunate enough to do a lot of work with National Geographic. And I was connected to Neil. He was on the show the first time a couple of years ago. And so we connected through National Geographic, and they've. I'm just amazed at the number of amazing people that I've met through them. And now there's Scholastic Press, which did the Scholastic books, Random House, and all these other publishers. And
so of all of the guests of yours that have been on the show, who do you think has blown your mind the most?
Wow, that is just amazing. Actually, it's a little bit like having to pick your favorite child.
Yeah. Okay, yeah. You don't want to discredit the others,
right? Just can't be done in some ways, but of course Neil is always fantastic to talk to. But just about an hour before we're recording this, I recorded an interview with Dr. Sabina Stanley from Johns Hopkins University, and she studies the interior of planets.
Oh, wow.
And we talked about that and how they're doing that. And I gotta tell you, that just blew my mind. It was pretty amazing. I get something out of everyone. I just really
that's beautiful. That's great. That's one of the advantages and beauties of the internet, I guess. If it is to be used for the better ever, then probably should be used for that. Would you mind telling a little bit about your background? For those, I like joking, for those 10 of my regular listeners, on a good day who may not have heard about you, how would you define your background in science?
Sure. I actually, my father was an electrical engineer who designed electronics for first the Apollo project, and then the space shuttle. And and so I literally grew up around rocket scientists. And and I remember he introduced me to a physics professor at MIT when I was about 10 years old, and so I've always been surrounded by science and always loved that. And I always wanted to make science entertaining, because there are a lot of barriers to learning and enjoying science, and not the least of which is the idea that science is boring, that it's dry. So what happens when we, I want to see what happens when we make science entertaining.
Yeah, that's beautiful. That's a noble purpose, I believe, and I think it's exactly the reason why so many people are appalled quite often, I would say, by science or anything scientific, is because their experience happened to be totally deprived of humor and fun, generally speaking. So once again, speaking generally about science, that should serve as a little introducing question. Do you think the science generally, it's a very broad question, is it on a decline or incline currently, considering basically internet explosion and the presence of a lot of conspiracy theories and those what about people, and famous people also, I think, as well as Neil deGrasse Tyson, get quite often criticized. I think it would be a fair estimation, criticized and misunderstood. So viewing the situation generally, do you think science is still getting more and more popular on the internet, I'm asking? I think there's really two questions in there.
The first
might have been more. I don't even know what
there
I
may
asked.
have been more. I'll address two of them. How's that? Is science? First asked, is science on the decline? And if you're looking at just science itself, we are. There's almost no question that we're in a remarkable age. There's so much data coming in, so many things to be learned and analyzed. And one of the things that's really going to enter into this is the rise of artificial intelligence. Because generative AI is very, very, very good at spotting patterns.
Okay.
And so you have all this huge flood of data coming in from all these observatories and satellites, and it's far too much data for even the entire human race put together to analyze. But now the AI is beginning to be unleashed on that. We are entering an incredible age of discovery. So I would say science itself is definitely on an unprecedented upswing.
Okay.
Now, people's understanding and acceptance of science may be a different story.
As always, the interpretation is the key.
Yeah, education and just how do I phrase this? We are really, really facing sort of a crisis of understanding in the world, and especially.
What do you think it's due to?
Yeah, I think there's a few things. Part of it is people don't. People have these barriers to science. Universities are incredibly expensive. It appears to be dry. So a lot of people have very little reinforcement from their friends and family. And another thing that we're looking at, particularly in the U.S., is a massive drop in literacy rates. I read the other day that something like only 57% of Americans can read beyond, a sixth grade level, which is
57?
57%.
Wow.
Right. Yeah.
I wonder if TikTok has got anything to do with that.
What's that?
I wonder if TikTok's got anything to do with that. Do you chalk something at least off to the, rise of those platforms? Or perhaps you're not one of those people that tend to criticize those, easily serotonin-given platforms.
I think, the platforms themselves, can actually be used as a way of getting through to people. Like, I went through a TikTok phase where I was creating these 1 minute, funny science films and putting them out. But I think there's always been an attraction of people for fluff. For the irreverent, and it
is what it is.
It can be entertaining. I've watched my fair share of parrot videos.
Of course, there's nothing wrong with that. Yeah, we all indulge in those things. I mean, definitely. So your focus seems to have always been mostly into the space. Would I be right assuming that?
Yeah, space, music, and entertainment, and and that sort of thing. And I've done all sorts of crazy things. With my time, I managed a science and nature store for a while. I wrote about 10,000 science articles.
10,000.
Yeah.
Dang. Over how long?
12 years.
Yeah. Okay.
It was a lot. I was clipping right along at about 6 a day.
Oh yeah. Wow.
Yeah. That was
In the context of space, let me jump straight into it. What the hell is the matter with the dark matter? No, pardon my cacophony of words.
That's great, and that's a great question. Okay, so when you look out there, okay, you're gonna see even if you count up all the stars, all the planets, all the comets, all the blah, 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 blah out there, all the dust that we can see, it still is only about 5% of what has to be out there for the universe to behave the way that it is. All right. And most of that, about 3/4, is about 70% is dark energy, which is another whole thing altogether. But about 23% is dark matter. Now, dark matter is exactly that. It's stuff that behaves just like matter, except for the fact that it does not give off any radiation at all. It doesn't give off any light. It doesn't give off any heat. It doesn't give off any radio waves, anything like that. But we know it's there. And the way we know that it's there is because as galaxies rotate, galaxies are big families of stars. And as they rotate, you would expect stars near the center to be rotating faster than ones on the outside. But it turns out they're going at almost the exact same speed. And the only way we've found to explain that is there's matter there somewhere, but we can't see it. So, hence the name dark matter. And also, when galaxies rotate around each other, they should fly apart, and they don't.
So something holds them.
That is dark matter.
Is that 100% ironclad explanation? Could there be a potential other explanation of why those objects are held together?
Right. In science, there can always be a better explanation. Arising, right. That's why we're here. But yeah, it's certainly possible that another idea could come along, but we have to explain all that.
Yeah, scientists seem to be permanently in trouble. Whatever new things arises, you will have to always explain it.
Oh, that's not trouble. That's the fun of it.
Yeah, sure, yeah. How was, when you said galaxies spinning around, may I ask how that got discovered first?
I actually don't have a good handle on that, to be honest with you.
Because you see, it's like, I feel personally, it's like one of the questions that I would also like to ask you is about multiverse. And the reason why I would like to personally bring the multiverse is because I throw that concept left and right kind of jokingly. And I've always kind of skeptically looked at that because to me, to a mind of a person who's completely and utterly distracted from all the scientific, sadly, because maybe I could have done a better homework educating myself, at least prior to this episode. It looks so much beyond even my attempt to comprehend it that I can't even possibly imagine. So I would like to know how all those sort of universally known but no least almost crazy concepts got even discovered, came about. Okay, so what about multiverse? Is that math? The fact that scientists claim that the universe is endless and there's a planet in which we are having a conversation like we're having a conversation, but you're wearing a different color jacket or your background is of a different color, or maybe I don't have the cringy beard. First of all, do you personally, I don't know if I should use the word believe, do you think that's true?
I think there's a couple of different ways of looking at the idea of a multiverse. And one of the concept is just extra dimensions. All right. We know of 3 spatial dimensions, up, down, left, right, forward, backward. All right. And any movement is a combination of those. And there's the dimension of time. So if if you're giving directions, you have to give basically 3 dimensions and a time dimension. I want to meet you for lunch. Okay, let's meet at the corner of 7th and 43rd Street on the 14th floor at 1 p.m. on Tuesday.
Oh, that sounds way too complicated. I would immediately have to ask to repeat that.
Oh, right.
Yeah.
All right. Let's imagine you're in a big city like New York City.
Yeah.
All right. And we want to make a time for the 2 of us to coordinate meeting.
Yeah. No. I mean, I totally understood what you've just explained. I just say that the address, the precise, location, just would sound too complicated. Like a quarter of a street on that floor, I would come to another country by that.
That's great. And so, mathematically, the idea of adding extra dimensions is incredibly easy to handle. There's nothing in the math that says that these ultra extra dimensions should not exist. And there's even some good reasons to think that maybe
like
they
what?
do. The laws of nature simplify a lot if you accept 11 or 26 dimensions.
Okay, damn.
Yeah.
Wow.
And so that's one idea of a multiverse. And now, if those are true, and there are other dimensions that are around, just because we can't see them, they're in a direction that's at right angles to every direction we know. Then, as I understand it, and I'm more of a planetary science person than a cosmologist, but the only way we would recognize, the only effect that we would see from these other dimensions is gravity. Like we'd feel the gravity of things that were in other dimensions, but we wouldn't see them. They wouldn't give off any radiation. And to me, I liked the idea that that may itself explain dark matter. Because there's nothing there but gravity.
What do you think? What do you make out of those people that, I don't know, just do not accept the, I don't know if I should call gravity a concept, but they just openly criticize it. And we can't but bring those people in because, some of those voices have been becoming more and more prominent and louder. Do you think it's pure arrogance, the inability to add 2 + 2, or is it, what is it really behind those people?
Again, I think there are probably several factors playing into that. The loss of literacy, the fact that there's less access to education. It's not being popularized in many ways. And there's a tribe mentality to it as well. If there's a group of 6 people and only one of them is interested in science, that's probably going to be washed out of their personality by the 5 other people who are
pretty quickly. So you do say that these things that I keep hearing personally about the endless amount of planets and probabilities and life forms and scenarios, it's all real. Is that what you say? At least real until proven otherwise, right?
That's the really cool thing about this. I think there's something to be said for that. But I wouldn't say anything is proven till unproven, and so far we have not been able to develop any machines or any tests which are capable of testing for other dimensions. So right now it's purely theoretical, it's purely mathematical, but that doesn't necessarily mean that it's not
that is
there.
Not true.
Einstein in 1905 and 1916 came up with his theories of relativity, and at the time they were mathematical, and it took 3 years or so until the first test could be done of that. And then it took all these other decades, and now we've tested nearly all of Einstein's theories to, better than 1 chance in 10,000.
So first it happened to be very theoretical, right? And then it proved to be real, tangible.
Exactly.
Almost,
right? And it turned out to be incredibly spot on.
Yet I'm also quite sure, although I can't support it by any particular examples, that there also have been a lot of mathematical, theoretical examples that later were practically disproven, right? Debunked almost. So it's interesting, I'm happy, and it almost gives me some sort of peace that you said that it still remains on a mathematically theoretical level, this thing about multiverse, because for some weird reason, I can't tell why this thing about multiverse has always scared the shit out of me. It's like, I don't know, honestly. I mean, maybe it's that fear of meeting your, how do you call that? The exact copy of yours, doppelganger.
Clone or doppelganger.
Doppelganger, yeah. Nothing about that word is friendly to me, to be honest. That sounds like the last thing I would like to meet, to be honest. Whatever calls himself a doppelganger, I stay away from that. So that's interesting. I feel like, there's a lot of, I don't know what the hell I'm talking about, but I feel personally like when a scientist says that something, that he admits openly that something has not been 1 billion% proven and it all remains on a theoretical level, I think there's some kind of relief in it, some sort of ease, for some reason. I don't know why. What is the easiest way to shut a flat earther? And I don't mean like shut him somewhere indoors, I mean to, prove him wrong.
I took an online class in science communication with taught by Neil, and he said, and it's interesting that he said that he actually enjoys reading things, about flat Earth theories and the moon is actually made of cheese.
It's fun.
Ideas, and he will, and I've taken the same approach that he will engage for the first time, sort of with these people and say, hey, well, why do you think that? Okay, well, wouldn't it be simpler if blah, 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 blah? And some people will get it, will learn more and go on, and other people will
stay defensive,
reject and stay defensive. And at that point, you just sort of have to say, hey, that's great, have a good life, enjoy yourself.
Yeah, and that's one thing I've not been able to just say, to be honest. I got my ass banned on a lot of communities.
It's hard to do that sometimes.
It's I've learned to hone it with time, to be honest. But it's like, what is that something? Does it say something about human nature generally? Our desire to prove somebody wrong, is that human?
Yeah, I think that's a very, very common, very human thing.
So anyway, getting back to easiest, most obvious evidence that the Earth is oval or round. I think round isn't the word, is it?
At the easy, the Earth, is a sphere, is what I call it at its most basic. It's actually a little bit wider at the bottom, and a little bit pear-shaped.
Wow.
Near the top. Okay. So
is that because of spinning?
Yeah.
Okay.
And cooling so I mean, there are several ways of looking at this. One is the fact that no matter where you are on Earth, a lunar eclipse will always show a circular Earth going, the shadow of a circular Earth passing across the moon. And the only shape that can do that is a sphere. And so I think, it would really depend on who you're talking to, and you can look at historical journeys around the world. Magellan comes to mind. So he, goes out and does this trip in, what was the 17th century, and he circumnavigated the globe in a time long before there was any sort of debate about it. Eratosthenes, Eratosthenes, he was one of my heroes in ancient Greece. He went by the nickname Beta. Because he said that he had no intention of being the best in the world at anything. He just wanted to be second best in the world at everything.
Makes sense.
And, and he noticed that a pillar and a well in two different parts of Egypt at different latitudes. One of them had no shadow at noon on the solstice, while the other did cast a shadow. And the only way to do that was with a curved surface. And he hired someone to walk the distance between these two cities. And he was able to calculate the circumference of the Earth to something like an accuracy of something like 98% accurate.
Again, pretty mathematical, right? Which eventually proved to be right.
It was. And,
have you ever, having experience that you've got and being who you are, have you ever held any debates, any public debates, perhaps with anybody?
That's interesting. I tend to put out so many shows and films and what have you that I have not been.
People like that, though.
And honestly, I'm not an orator. I'm not a person who can go up there and give speeches, and I'm not terribly good at debates. I love the process of being able to put pieces of information together, whether it be writing or video or podcast, whatever.
And do you know perhaps where this whole flat earth theory even takes place, how it even originated, what pushed it, if you know?
I mean, the earth does seem flat to those of us here on Earth, you know? And it's probably an easy conclusion to reach if you're not looking too deeply into it. And, I also think that there's a huge crisis in confidence in anyone who at any point ever called themselves an authority on anything.
Oh, wow.
Interesting. I mean, because we see so many governments and corporations and world leaders and entertainment people and all this just failing what we once believed them to be, and in some ways it's kind of like the end of The Wizard of Oz.
I've never read it nor seen it, to be honest. I'm embarrassed.
Right. Yeah, I'm not going to spoil the ending for you, but I've been intending to. There's a great, there's a scene of a great unmasking, let's say, at the end, and
is that a bit of a plot twist, a bit of a curveball, when something like that?
But anyway, so I think that there's been such a loss in the human trust for anyone or anything that it's hard to believe anything at this point. And if you don't understand the tools of science, it becomes really hard to understand why these things happen the way they do.
Well, enough of conspiracy theories. I think we've all been given a fair share of those over the time. When it comes to the origin of life, is there a bottom line in that matter? Is there a bottom line answer as of to what originated, what started that? Because different people tend to believe different, and what opinion do you hold?
Life is so cool. Now, what's really neat is that life, well, first of all, how do we define life? You know, there's a lot of different ideas on it. But life is, if you're going to define life as something which can both reproduce and heal itself, then something like life began almost as soon as the Earth's surface was cool. You know, our Earth, you know, our planet formed as, you know, magma, molten rock, and started to cool. Oceans formed. Bam! We had something approaching life, and so it appears to be common. It seems, my gut feeling, and from what I've learned from, you know, laws of chemistry and physics, is that life appears to spring up almost any chance it gets. No matter where we look on life, underneath Antarctica's ice sheets, under the depths of the oceans, you know, there's life of some form.
Yeah, it sounds as a slogan of one horror film that goes like, life finds a way.
Yeah, right, exactly.
And that actually was probably the horror film Life. Have you ever seen it, perchance?
You know, I have not seen that one. You watch The Wizard of Oz and I'll watch Live. How's that?
Yeah, that's a deal. That's a deal. Yeah.
And, you know, and everywhere we look out in space, life, we find the ingredients for life. You know, you look up in these dust clouds and we find all 20-odd amino acids that are essential to life on Earth. And if these things are just spread out everywhere, life could be ubiquitous throughout the cosmos, just found anywhere that it could possibly get a foothold, or a clawhold, as the case may be.
Yeah, it appears in the second form sometimes. Yet, why haven't there been any proven form of life on other planet if life appears to be so, you know, ubiquitous, as you said? What do you contribute that to?
There's a few reasons. And first, you know, to quote Douglas Adams, space is big. And so there's going to be, you know, different forms of life. If there's life all around us, it's going to be difficult to find as it is. And for most of the history of life on Earth, there's been no life except the most primitive bacteria and unicellular animals. And so, you know, little one-celled animals aren't building radio telescopes to say, here we are, you know. But this is so cool. One of the things that's really neat is the fact that even at that point, life had radically changed the atmosphere of Earth. It, you know, and eventually went through what's called the Great Oxidation Event, when Earth, you know, just all this oxygen, about 20%, formed in our atmosphere. And there are other gases like methane, which are there in much larger amounts than we'd find if there weren't life, which means that there are chemical markers for life, even the most primitive life. So now we're getting very, very close to the point where what we're doing now actually is to look at the chemical compositions of the atmosphere of exoplanets, of planets going around other stars, and looking for those chemical markers. Which means for most of the last, 70 years that we've been looking for extraterrestrial life, it's only been intelligent life, what we could see popping up in radio telescopes. But now we could examine the atmospheres of other worlds, and that's what's going to give us our first.
You think we're on the brink of some big big discovery? In how long? How long do you think? Are we getting really soon?
I would think, and actually, these chemical markers are also being looked at on worlds closer to Earth, like some of the moons of Jupiter and Saturn. All right, like Europa, so I really think we're going to start seeing the first good evidence for life on other worlds in the coming years, next 2-3 years.
Yeah, so as our instruments get better.
Right.
How
and
do we, when you
has
said...
to go on as well.
So when you say, as we look at Europa, for example, how do we even look at that? Is it through these super fancy advanced telescopes? How does that happen?
The super fancy advanced telescopes definitely play a huge role now. And NASA is also planning what's called the Europa Clipper mission, which is going to head out in a few years to go take a close-up look at Europa as it orbits Jupiter, and do some real in-depth analysis on it. But and then you match that with data that's coming from Hubble and Webb and what have you. I think we're going to find some real interesting chemistry really soon.
It might have been actually exactly Neil deGrasse Tyson that first introduced me impersonally, so to speak, to the idea that we actually could be the first, at least in nearby vicinity, right? Is that too far off of a possibility? And if we are, in fact, the first and therefore the only, is that equally scary as if, there are neighbors?
Yes, it's absolutely possible we're the first. But, if Earth contains the only life in the universe, it's an awful waste of space. All right, so now we know of roughly 60 million different chemical compounds. All right, but half of those, about 30 million, are carbon-based or organic, and that means that all these complex chemicals are almost certainly going to be found almost everywhere. So I would be really, really surprised if we were the only life, let's say, in the galaxy. But one thing that certainly plays a role in it is how long a technological civilization lasts. Do we take this opportunity to move beyond the star, move into the cosmos and move into a post-scarcity world where there is no more hunger or homelessness, or do we destroy ourselves in an afternoon of nuclear war, or kill ourselves with any number of techniques,
If you had to bet your money on aliens have visited us versus they never have, which would you opt for?
If those were the only two options, I would probably have to go for never having visited, just because space is so huge. But I think that I think there is a chance that some have. And what's maybe even more likely is, instead of having biological aliens coming around, they're drones interstellar drones are probably.
Oh, I thought you were going to say some sort of extra-dimensional aliens. That this term gets thrown around quite often recently. Those that have always resided by our side, but we couldn't easily spot them. So one more thing, when you say the space is huge, is that a supposition or is it an axiom?
I don't know if I'd either call it either one, but it is certainly a well-tested, well-supported model of the universe. It's possible it could be, we think the universe is about 13.8 billion years old, and there's a lot of evidence to back that up. And, but yeah, there are some questions and some uncertainties about the size. I think we're probably coming close to the best possible answer, but I don't know if I would necessarily give it the title of an axiom.
What do you make out of the supposition that says that if the aliens have in fact visited us, it could have been us that left the Earth at the peak of one of those civilizations' development, and now, we kind of visit ourselves, but it's them is actually us. What do you make out of that? I'm sure you've looked into that.
It's possible.
Yeah.
It's certainly an extraordinary claim.
Which needs extraordinary proofs, as Carl Sagan said.
Extraordinary proof, right? And that's not there. I mean, and I would love for it to be there. That would be so cool. I would have someone from the future on the Cosmic Companion.
Oh, that would be amazing.
Anytime.
That would be amazing. You said you would love for it to be truth, and so would I think. But how do you think would religious people perceive that? Wouldn't that undermine all religions in the world?
It may. I think there are probably several pieces of evidence which contradict a lot of religious teachings. But I think I can imagine if we had absolute proof of life on other worlds, for instance, that could cause a huge backlash amongst religious people and organizations. But I think you'd probably have the average person on the street would probably be, even if they were religious, would just think, well,
he would be fascinated.
Here we are, and this is cool, and.
Yeah, I wonder how they look like. I wonder if I can talk to them. What the hell can they tell me? I wonder if I can make a TikTok with them.
That's great. Actually, I've heard. I am very, very much into artificial intelligence, and my wife Nicole Hennig is an incredible expert on the subject. And I've heard from people who are developing AI that it is quite possible that generative AI could teach us to talk to animals, including our pets, within just a few years. And so I think if, aliens were to come down to Earth, arrival style, or that AI would probably be a first tool we'd want to put towards trying to translate their language and
that would be good.
Communicate with them.
Yeah, well, cats have to be first, I bet. Animals, pets must be first as a testing model, right? Do you view AI as a threat, as a lot of people do, potentially in the future?
I'm sorry, what was that?
Do you view AI as a threat, as a potential threat in the future?
I see fewer threats from it and more potential benefits. But think about what AI represents. It gives us the power to ask questions that humans are not even bright enough to ask. You know, if you try, you might have a smart dog or a smart cat, but try as you might, you're probably not going to be able to teach them quantum physics.
Hell no.
Right? And so, likewise, the human mind is almost certainly limited like that. There must be all sorts of branches of knowledge and understanding that we cannot possibly comprehend. And AI could soon start asking questions that no human on Earth is bright enough to even ask.
Yeah, but that's interesting because we're still the creator. So I think that comes down to fundamentally the question of, can a creation supersede the creator? You know? And you believe it can.
Yeah. And again, I don't really hate to keep putting Neil deGrasse Tyson into this, but but when we talked about AI last time he was on the show and on the Cosmic Companion, and we as he put it, the AI could become as intellectually superior, supposedly, to us as we are to pets. But for the most part, it's not always the case, but for the most part, pets can be, humans treat pets pretty well.
Yeah, okay. A lot of people wouldn't want that perspective, to be honest. A lot of arrogant, I guess, people, kind of full of themselves, they wouldn't want that.
Yeah, I mean...
Wow, that's interesting.
Yeah.
That's interesting. Man, so many questions I'd like to ask, really. Getting back to cosmology, if I may.
Yeah.
Why haven't people returned to the moon?
I think that's probably more politics and human nature than cosmology. But, okay, so so when the Apollo project started, the Cold War was on full speed, and the U.S. and the Soviet Union were rushing to see which one could put a human on the moon first. And so, but once the U.S. actually did that, that goal was met, to beat the Soviets to the moon. And so then there wasn't nearly the push in government.
Okay. The incentive was gone.
Yeah, to give NASA both the attention and the money that they needed. At the height of Apollo, NASA was getting about 4% of the NASA budget, of the federal budget. Now they only get about 0.5%, 1/8, relatively, of what they were getting back then. And
so they got to be more careful with how they spend it.
Well, I mean, the feds certainly need to be more careful with how they spend money. They should be putting a lot more into science and technology, if you ask me. And for an interview, I guess you are asking me. And so the other thing too is that the folks at NASA thought, okay, well, if Apollo's coming to an end, the next thing we want to do if we want to go into space is to have a regular presence up in Earth orbit. So they put Skylab together. That had issues right from launch, but eventually got into an orbit, was visited by a few crews. But while Neil Armstrong sets foot on the moon was a great news story to go around the world and generate public support. Skylab whips around Earth for 10,000th time. Isn't nearly the news story. Yeah, go boring. And I think people really lost interest in space a lot at that time. And of course, then you have the shuttle, which was a brilliant piece of machinery, but it was sold to be this space plane that could go into space every couple of weeks, and we're going to build a fleet of them, and we're going to have all these space shuttles. But reality was, it was taking 6 months to a year or more to get these shuttles, cleaned up and ready for their next flight. And it really sort of, I hate to say this, but the, fancy line of little sports cars they had claimed they tried to get out there turned into like 4 or 5 big dump trucks.
Yeah.
And of course after the Challenger and then the Columbia disasters, it was just And so,
are you talking about that shuttle getting up and exploding before people's eyes?
Challenger in '86. Of course, put a halt on the shuttle program for a couple of years.
Right.
And I think, the next best hope for human spaceflight is probably going to be a human mission to Mars.
Mars, yeah.
Because that holds that same sense of adventure, that same sort of sense of wonder
excitement
that Apollo had.
How well is the moon studied?
The moon is actually been studied fairly well. There are different spacecraft that go around. The Lunar Reconnaissance Orbiter is one of them. And so one of the big things about studying the moon now is looking at the South Pole, taking very, very careful maps of the South Pole. And that is because we believe there is a whole lot of water there. And the reason that is because craters in the South Pole never see sunlight. So they remain completely dark all the time. And they've been dark for billions of years. And so that means that any ice that comes into them, like when the craters formed through comet impacts, and comets are basically big dirty snowballs, that water just stays there. And it's thought now that there may be as much water at the South Pole of the moon as there is in the entire Great Lakes system of the U.S.
Wow.
And so if you're going to have a permanent station somewhere on the moon, that's where you want to be, is at the South Pole.
Wow. That's interesting.
And so everyone's studying it. The U.S., Europe,
that seems
China,
quite promising.
India.
Yeah.
And that's going to be our first home there. And that's, I think, that's really the hot spot for...
Right. That's the vacation spot, next probably couple of tens of years. What is, I don't know, I mean, I know that question is kind of initially deprived of a definitive explanation and answer, but what do you think caused Big Bang? That's a Vogler question probably to a scientist, right?
The Big Bang is one of the greatest mysteries we could uncover. Basically, there was nothing at all before the Big Bang, and except for this nearly infinitesimal, tiniest little ball of energy that held all the matter that we call the cosmos. And it looks, again, this is something that we can really only study mathematically. If you rewind the clock on the universe and it shrinks down.
It shrinks, right.
The laws of physics make sense right down to about 0.0000042 zeros and then a 1 second after the Big Bang. And then all heck breaks loose. Physics becomes almost useless.
So you said before the Big Bang, before that, there was the bang, the explosion. There was this speck of something, right? That held all the matter and everything that eventually came on stage, right? But what was that spec? Do we know what? No, we don't. And again, that spec is almost, I feel like, a mathematical approximation almost, in a way, right? Almost, because that's as best of an explanation as we could come up. Because if everything shrinks, everything comes down to this, it must come to something. It can't probably come to absolutely nothing. And even if it does, then what triggers the explosion? Now, let me ask you this question. Yeah. So do you think the comparison of Big Bang and whatever propelled Big Bang, so to speak, do you think that's a fair comparison to the concept of God?
I think it depends on how you're going to define God.
Yeah.
If you're, talking sort of the traditional sense of a, big guy with a beard and a white robe.
I think that's more of an image that's been somehow modified for cultures and for certain purposes, but if we define God as a power that triggered everything, that, built everything, and those different scriptures, they just primitively, perhaps due to the time, explain it, because I feel like both of those theories, they have a lot of questions, and eventually they all come to nothing. Like, okay, where did God come from? What caused the Big Bang? Do you think that would be fair to? Is that offensive to a scientist to compare those two? No. No,
I can't speak for all scientists, but for me, I would not ascribe to any sort of, more traditional religions or anything, but I find a great source of spirituality in what we know about the science of the universe. All the atoms inside of you were made, some of them were made after the Big Bang, but most of them were made in stars, in the hearts of stars that were born, lived billions of years, and died. And when you die, your body's going to turn back into atoms, going to turn back into earth, and grow up and, become plants and get eaten by animals. And so I think there is a truth in, referring to nature and the oneness of it as God. Although it's not typically a term I would use, I do believe that there is some
unity,
some ways
in a way.
of using that word.
Okay, yeah, that's interesting. That's beautiful, and I think that remains the number one question. Actually, this whole thing, it's to me, and obviously, I'm not in a position of making a conclusion of which aspect is of a bigger utility and which is not, but whatever caused the Big Bang must hold a special priority, and so it's just fascinating, I get carried away thinking often about what could have even possibly. Are there any people that think they have some explanation? Have any explanations been thrown out there?
Oh, sure. I think that Michikaku has written, several great books about it. Hawking, before he died, had a lot of thoughts.
And what are those guys saying?
Now, it's been a while since I've really looked into what they did.
Must be something terribly complex.
Right, something terribly complex.
Yeah.
But one of the ideas I've heard is that the energy in this, primordial, I hate to call it a primordial egg, but has a certain rest energy to it. Okay, it's kind of like the energy could move, but it was like in a bowl, and the probabilities said, most of the time it should remain within the bowl, but then the numbers just changed and zapped it into an energy state that it shouldn't.
Which propels even more questions, fairly speaking.
Set the whole thing off. But what's cool is that when you look at the math of what should have happened if these ideas of the Big Bang were correct. The mathematics predicted that the echo, if you will, the electromagnetic echo of the Big Bang would slowly cool over time. The wavelength would become longer, and that it would now be seen in microwaves. It was first forming gamma rays. It would now be seen in microwaves. And sure enough, when we sent up microwave satellites to map it out, not only was that microwave radiation there, the energy curve that it followed was exactly what
as it was.
Mathematics had predicted. That was as one of the biggest proofs.
That's beautiful.
For the Big Bang.
Beautiful. Who is that person? Who's that main source behind this shrink theory?
Not sure whoever.
Because whoever that might have been, he, I don't know, must have been the luckiest, if the word lucky is even applicable here, but, you know, the guy probably spotted arguably the most important thing about the whole humanity. You know, being able to mathematically track it all back from the beginning to the current stage and vice versa. That was big. You know?
I've heard that. I've heard that idea and that concept from so many sources. That the original.
Yeah, that'd be nice to know. Yeah, that'd be nice to know. Well, I'd like to finish on a note of science fiction. Perhaps you're familiar with the works of Philip K. Dick. I'm getting deeper and deeper in his novels and his stories. Have you ever read that author?
Not as much as I would like to.
Yeah, such a great author. I can't recommend him, strong enough. You will definitely like it. I'm reading his short stories compilation. It's like every single story is about this. It's fairly creepy, but at the same time, well, considering the year when they were written, which I imagine the 60s, but it's like he was a prophet of his own day, Yeah, so good, predicted so many interesting things, and the AI is pretty prominent in his novels and stories. So, I wonder, what do you think is, do you read science fiction?
Oh, I do, actually.
Yeah.
And of course, when I was a kid, I absolutely loved Asimov. And I adore the works of... I can't even think of her name. She wrote the Xenogenesis series. Octavia Butler.
No, I never heard of her.
Yeah, she wrote a trilogy of books, and Ursula K. Le Guin, and I love how science fiction can really shine a light on the possibilities.
Yeah, because those authors are not limited by what scientists in science have got now, right? They kind of unleash their imagination, and quite often it turns out to be truth eventually.
And what's sort of interesting is that, there's since the beginning, really, there's always been two schools of sci-fi. One that was, led by Jules Verne, and who paid a lot of attention to science. But made it entertaining, like I try to do with The Cosmic Companion. And that went to, let's say, Star Trek, which is fairly scientifically literate.
Oh, yeah.
Sci-fi. And then there was H.G. Wells, who did more fantastic things, more moralistic tales, without paying a lot of attention to science. And of course, we're seeing that school of thought in, Star Wars. Yeah,
beautiful.
What do you mean it was Kuiper crystals? That's just silly.
Yeah.
And
well,
so that's really interesting to me.
Everything seems to be pretty interesting, and I'm pretty happy that our episode turned out to be no least interesting. And I quite often feel disheartened for the fact that too few people will hear episodes and guests that I am privileged to have had, and you're one of them, for which I'm endlessly grateful. So thank you very much.
Thank you.
Appreciate
Great
you
being on the show, and check out The Cosmic Companion.
Hell yeah, everybody will do that. Do not expect the whole concourse of people coming to your channel from my... Yeah. Bam. Okay.